Hi, in this video we're going to see how the ARP protocol works. In fact, you can either call it ARP or ARP. I will pronounce it as ARP for the sake of simplicity. Let us start first with the problem statement, that is, why we need ARP. As we know, hosts usually have two types of addresses, IP or network address and MAC or link address. IP addresses are hierarchical and indicate somehow a location in the network, while MAC addresses are completely independent and are usually randomly assigned by the manufacturer. As we can see in the example, IP addresses of closed hosts are somehow similar, while MAC addresses could be drastically different. These are different, while these are similar because they belong to the same network. So what happens when a host wants to send an IP datagram? A communication is established at layer 3, the network layer. However, when the real or physical communication occurs, the network layer sends the datagram to the link layer, which encapsulates it into a frame and later on sends it via the physical layer. This frame reaches the destination link layer, which decapsulates it and sends it to the destination network layer. As it can be seen, each of these layers have its own addresses. More specifically, if we check at the messages exchanged in the network, we will have an IP datagram with two well-known IP addresses, but at the link layer, we do not necessarily need to know the destination address. As we can see here, this is unknown. Why? In a very simplistic analogy, if we are thinking of somebody sending a letter, we could say that the network address here, for example, is equivalent to the address written in the envelope, while the link layer address would be equivalent to the specific GPS location. Therefore, before sending the letter, we need to check the specific GPS location of the address in the envelope. So ARP, in this case, would be similar to Google Maps. Sorry for the spam. In some cases, we might already know the GPS location because we have already been there or whatever. But generally speaking, if it's the very first time, in this case, the very first packet of the communication, we will then have to check it. This task is performed by the ARP protocol, which we could say is located in between layers 3 and 2 of the protocol stack. So how does ARP work? Each host interface usually has a table, also known as ARP cache, that contains the IP address and its associated MAC address. This table also has a timer for each table entry, as we can see here, but we will simply ignore it for the simplicity of the explanation. Let's see how this table is populated in the following example. In this case, we have 4 hosts, and IP addresses are shown in red, MAC addresses in blue, and all ARP tables are empty because the host has just been switched on. In this case, host A wants to communicate with B, so the first action will be to send an ARP request. This is the first message. If you see, the destination address is FFFFF or Fs, which is a broadcast address, and the source is the MAC address of the host, the source host, okay? Inside the request, we have the following information. We have the source MAC, destination MAC, and the destination MAC is unknown, so we set it to 0, and the source IP and destination IP. This ARP request will reach all hosts in the network because it's broadcast. Even if C and D receive it, they will not reply, because they check it and it is not for meant to them, okay, so they just ignore it. But B realizes that this ARP request is for him or her and saves it in its ARP cache. As we can see here, the tables are updated with this associated. Afterwards, this host will reply with an ARP reply. So we have basically two main messages, the request and the reply. This reply is a unicast message. So in this case, the destination is W because we already know it from the previous request. inside the reply we have all the information. In this case, the reply will traverse the network, and C and D will not even receive it because it's a unicast frame. Finally, A saves it in its ARP cache, and then after saving it, they can send the information right away and communicate as usual. What happens if the destination and source host belong to different networks? So in the previous example, all hosts belong to the same network, but if A and B belong to different networks, then A has to first reach the router. In the simple analogy of the letter and so on, you can imagine this as if you have to send a letter to a friend. So you have to go first to the postal office, and then the postal office will go to your friend's house. Okay? So if you don't know where your postal office is, you first need to check the GPS of the postal office. Okay? And then the postal office will have to check the GPS, let's say in a very simplistic way, of the friend that you're writing the letter. Okay? So in this case, you know the destination, you know the address of your friend, but you don't know the address or your postal office, and this router would represent the postal office. Okay? So the IP addresses of the source and destination will not change because your letter in the envelope has always the same destination and source. But what changes in between is the physical address, okay? Because you go first from your house to the postal office, and then from the postal office to the destination or your friend, okay? So let's go now for the real example with the network, okay? In this case, when A is sending the information to B, A will realize that B belongs to another network, okay? So in this case, it produce an ARP request as in the previous example, but in this case, instead of asking for the MAC address of B, it will ask for the gateway MAC address, because the gateway is the router, okay? Okay, A realized that B belongs to another network, so instead of asking for B, it asks for the gateway, which is D. So in this case, the ARP request will reach the router. Once again, C will see it, but will ignore it. The router will then save the information, okay, as we can see here, and reply with an ARP reply. Once we have reply, A can now send the data to D. So it sends the data, and when the data arrives to the router realizes that it doesn't have the information for B. So the router checks the IP datagram and sends a new ARP request. In this case, the ARP request goes from E to B, as you can see here. B will save the information and will reply with an ARP reply. Eventually, when they all have the information, the router will send the data from the receive in the very first place from A. Okay. In practice, this is not usually happening like this, okay, because usually routers are not saving the data. They just send the ARP, and the first data sent is lost and something like that. But in any case, this is very theoretical. If you feel curious, I'm leaving a link in Blackboard just to check it. And that's all. So, thank you.